Okay, so this is my interleaved DC-DC boost converter. It's two-phase, it's smaller than a credit card. Here's a AA battery for reference. This is good for being powered by a 9-volt battery using this battery clip here, and it should produce an output anywhere from the regions of about 13 to, and I've had it up to 38 volts. The output for this one was designed to be 24. So I have my output power and output ground hooked up to my digital multimeter, and this is current voltage reading on the output. I then have my 9-volt source on this clip hooked into a stable power supply rather than using a battery, so that the cell voltage does not drop. This one's running at 9.1 volts. It's currently switched off. And then in this corner here we have the 3.6 volt logic supply for the MSP430 that's being used here, microcontroller. So if I first turn this guy on, you should see this LED here turn on. There we go. So that's now on. No significant change in the output because it's only switching, so I'll just turn that off. Let's turn the output for this guy on. So it's running at 9 volts, drawing negligible current, and the output LED turns on. We have 8.87 volts across the output load. Now if I turn on this guy, the LED should get brighter and the voltage should change. So we get 24.58 volts. The output LED is significantly brighter, and the LED is also on the microcontroller. And we're drawing about 60 milliamps, or on the order of 60 milliamps. Turns off, turns to 8.87, turn it back on, 24.58, and it's very, very stable. Doesn't appear to be much variation in the voltage. If we turn this guy off, back down to next to nothing. Turn this guy off. There we go. Now if you have a quick look here and here, we have placeholders for some high value resistors, very low current draw, that go to an analog to digital input pin on the MSP430 microcontroller. Basically if you read the value off that, you modify the control algorithm to vary the duty cycle on that. You can respond to changes in load just by varying the duty cycle. As I said before, I've tested this guy from 13 to 38 volts because I didn't want to push it too high because of the breakdown voltage on the Zeners. But everything is oversized. The MOSFETs don't even get warm, and neither do the inductors. Output resistor gets a little bit warm, but aside from that it's all good. The simulations that I did before showed good promise for output voltage ripple, capacitor current, and also the peak currents through the inductor. The schematics, design calculations and the printed circuit board layout have been included in the report for your reference.